at another data structure. Before that, I'm just want to quick review. I give you a refresh your memory why we need to do ideas, right? Ideas needed to improve your application as fast as possible from the algorithm perspective. There is so that's the reason if you properly use that algorithm and then as well as data structure, you will be gain better performance and also this some resource will be saved. For example, space will be saved and the memory size will be saved, so you will be get better performance. So it's kind of the course that you optimize your application, optimize your program, optimize your system. Okay, in other words, so that's it. We needed to uh, algorithm data this course. And then sometimes in order to, first of all, in order to understand, we needed to measure those criteria. We take this criteria in the application. We come to the only two criteria. There is a time complexity and the space complexity. We tend to uh, as fast as possible in certain time, as safe as possible in the minimum memory usage. So that's a very important aspect in the algorithm data structure. So that's the reason we come to the only two criteria: space complex, time complex. Okay, that's important. But how you can measure that? For example, we weight we can use it gram, kilogram, ton, right? But space we will use for example meter cube, right? Centimeter cube, for example. But how we can measure the algorithm, right? So that's the reason we introduced the big O concept, O1, ON. It is O1 is fixed time, ON is linear time. Then as well as what is this? Login. It is a to base the login. By the way, it is 1,000. What 1,000 of login is how much? Is do you remember? 20, right? Um, then as well as n login, those are we give the example. So that's the reason we all the time we say the application of such operation, such function is login time complexity or quadratic time complexity or linear time complexity. So that's the reason tend for that's fast or slow, then or maybe it's better than previous one. So you can say, okay, that's the previous one is quadratic time complexity. Now applying this algorithm using this data structure, or they gain this linear time complex. So we just improved it. So that's good. So that's the beginning of the warm up the algorithm. And then at that time we didn't we quickly introduced the two data structure, stick and the cube, because of the very special. That's the reason we also trying to let you how we can measure those algorithms, how we can understand from the algorithm perspective. That's the reason we introduced that. But today it's very important. Linked class. This is most of the very fundamental data structure. Use that linked class mostly applied, and then other data structure also will be used at this linked class. For example, is today's Q Q and stick also can be used linked class. Also can be used the array list to create such algorithm. But so linked class is also important. But before that, we also something we need to compare with them. For example, array list. This is both are very similar. I mean, we can. This is kind of list of collection. For example, would say not arrayless. Let's say maybe you can confuse it, so you say array. That's it. So compared to array to linked list. Okay, so first of all, you needed to, so most people familiar with the array. So what's the arrays? Of course, continuously located in memory. So we will be trying to compare with them, but nevertheless, the both are linear data structure. So it's similarity and difference. Then after that, we give the introduction of different type of linked list, purpose and different operation, and then come to the with data structure measurement unit. As you know, time complexity and space complex perspective to introduce them as well. Then, of course, there is a finally there is another linked list. It's being called doubly linked list. It's kind of circled linked list, several types that we will be introduced to one of them, double linked list. Then also we will be give the example how we can create with C++. Then we will be a little bit review and then analyze to a certain source code to explain how it look like. Then you can able to feel about in the future or maybe certain time. So that's agenda. Let's start. So first of all, we should understand, trying to understand, the array. You probably already heard about the linked list, but doesn't matter. If you didn't know, that's first time. It's you say that both can be stored certain information. For example, A, B, C, D, E, F. They can also save the same content. For example, A, B, C, D, E, F. The difference is the array is continuously in the memory being located. For example, if I know the location of the A, I know where is the B is located. Then also C, D, they will be continuously located one beside another. So that's a very distinguished feature in the array. So it's continuously memory location. Okay, the location is continuously. A memory address is so it means that's the reason usually array only one pointer existed. So if I pointer give them pointer one pointer, so it's very easy to I just moved one another position. For example, I know the pointer pointed to A, then I know find the D is I just need added to two position, then I can find D. So no need to specially find. So that's the reason index being called it. So I can just remove it or forward and backward. I can find it. So that's it. That's the array. But linked list in the memory location is distributed, not continuously located. So as you can see, for example, A is located in the memory somewhere else, but B is located in other place, but it's not the continuous. It's not the neighbor. Okay, there is a in between. They will be linked with some pointer. So they will be actually use it many pointer as long as how many there is a one concept being called node. The node is included two things. One is value, another is a pointer. So as you can see, there is a A's value. Same time they have another pointer, next pointer. Who's the next to me? It's the B, so they will be pointed to B. This is a pointer of the location. Then actually the memory address pointer, it means memory of the address, right? And then B is also, there is a B of node, there is B is the value. Actually, this being the node is included the value and the pointer. So B also pointer to C, and the C value next of them is pointer address. Then direct to the next value, you can get this value, as well as in the next is they have a pointer. So it means that's look like distribute memory address, not continuously. So that's the reason there is a little bit difference. When you compare it, there is will be a pointer will be used it as a little bit extra space, right? So for example, each of the value has a pointer. So in this here is 1 2 3 4 5 6 value, but they have a 6 pointer. So in order to save the pointer, I mean, we needed to pointer, so they needed to actually extra space need. But for array, there is no needed extra space, so it means a little bit save time, but doesn't matter. It's just 1 bit space, right? But nevertheless, that's kind of difference. So as you can see, that's first difference. As you, there is also give them, if you're interested, there is also give them a reference. You can very close to look at this article you can learn from. For example, probably this one. Let me just quickly let you, maybe we can review together. I think, okay, right, this one. Actually, except that hash table we will be introduced in the future, but this is very kind of different. That's also very good article. At the same time, they compared array, linked list, and then hash table. So that's good. Even without know what the hash table is, actually hash table is key and value. You so it's being called. I mean, in different language, being called it different name. For example, in the Python, being called a dictionary. I think in the C# also being called a dictionary. But in the Java being called hash table, and C is also called it hash tables as well. So as you can see, that's a graph actually I can reference from this article. So as you can see, there is a they can explain what it is, how, what's it, what's the pro and the cons. They can explain them. Basically, you know, as you can see, its array is better to access. I mean, you can access any element in the any position. You can directly access by the index. So that's very fast. You can read, if you read only operation, we just recommend to just use array. But if you delete it, delete and the insert operation, um, for example, because the array is continuously location, let's say you want to delete the B, then when you delete the B, first you need to find the B, after that you can delete the B, then all of the C's moved in the replace the B, D also replace the C, and then E is replace the D, F is replace the, I mean, E. So it means that you need a whole line of the H element needed to move. So it means it's a little bit time consuming. For that reason, linked list doing very quickly. They just needed to needed to, you know, impact other element. They, for example, they wanted to delete D, they just delete it. Then the C of the link just redirect to E, that's it. So actually, this is a delete operation is redirect the pointer to E. It means isolate the D. I mean, they can able to, you can you can release now the position. Yeah, so that's so it means that's the reason the linked list is good at to insert and delete. As you can see, in order to delete and insert, they just need to fix time. Right? But this one is linear time. Delete is linear time, because when you delete it, they will be, I mean, worst case. I'm talking about worst case. If I'm deleting the A, I'm moving to all of them. If I deleting F, maybe it's a fixed time, right? But it's not all the time happen. Maybe this happen is different position, then it is approximately linear complexity. But this one is fixed time. So deleting and inserting is linked list is good, but accessing, I mean, finding the element, it's not efficient as array, because you're trying to find, you cannot directly, you can find E first, but you need to start from the, say that this is I'm not saying I'm not saying E. So if I'm trying to find E start from the beginning, the head, they'll say it's not the E. So they go to the B and they go to the C, go to the D, then find the E. So it means approximately that's the linear time complexity. But for arrays, accessing is fixed time. Right. So that's the reason. That's pros and the cons. Okay. But I just want to quickly explain what's hash table. Hash table is good at for not only the delete and insert, as well as accessing is also fixed time. All right, so it means look like this hash tables better than both. I don't think so. It depends on what the hash table is, but if it is hash table enough, is efficient, then as you can say, hash table is search, insert, delete is always fixed time. But this is average complexity, average time complexity, as you can see. But as you can see, insert and delete is linked list is better, fixed time, right? But for the arrays, linear time. For access is linear time, so that's the reason if you read only, recommend to array, but linked list is not good at, because linear time complexity. For example, you're trying to find element in the 100 element, the average cases they will spend 100 times. I mean, minus 1 times for average case. What's the average case is most time of the 90% of the things been, I mean, the most time is average case. So as you can see, if your average case is better, then this algorithm is better. I mean, but delayed insert is good for linked list. Delayed insert is hash table. Also, search is not, searches also hash table is good, but search linked list is linear time. But we are not, but worst case is very rare case. So but we try to avoid worst case, but nevertheless, if you not choosing properly hash function, this is all the time linear complexity. That's the reason. So depend on what's the hash function is you choosing. If you're choosing the good hash function in your situation, then hash table is better than both array link and linked list. But if you're not, then it's not good. But as you can see, linked list, whatever the worst case, they insert delete is always fixed time. So that's a very stable algorithm. But but in the array, what's stable is accessing whatever the average case, a complete worst cases, both is fixed time. So we can able to make a conclusion, right? So if you read only operation, trying to access, please recommend to use array. You will be get better performance, because it's fixed time. Fixed time doesn't miss one time. Keep remember. Maybe fixed times 10 times, maybe fixed times 100 times, but compared to size of the element. For example, 1 million of the element, you just fix times 1,000. Okay, then it doesn't matter, right? It's very short. But if you fix time is the size of the 100, but the time is 50 or very 80, then it's the problem. So depend on situation, you need to think about it. Linked list is good for insert and delete. Insert and delete is all so, but hash table is good at for all time, but depend on hash function. Okay, but don't worry, hash function, hash table, the data structure we will be introduced in the future. Okay, not in this time. So this is also good article. Please go to the try to understand, read this article, more theoretical one. Okay, so you understand linked list and the array list, right? Any questions so far?
No.
So why we needed to, there is I can store data in array instead of linked list. So it's no problem. You can save the same content. It's actually actually the linear data structure. Or why maybe I'm take the chance trying to clarify what's linear structure. For example, if you're trying to store an element linearly, they also have a relationship in between each information that's been called the linear data structure. For example, linked list, array, it's been called linear data structure. But sometimes, some data structures not linearly represent. For example, in the C++, for example, there's a thing called structure, right? Structures composition data structure. But if you put several things together, then also there's a tree, tree data structure, binary tree, black red tree. This is also data structure. It's not linear. Then also graph. For example, Facebook in the context relationship, people to people relationship, social network. So those are we can use graph data structure. It's not linear data structure. So that's the reason I'm talking about that. That's the reason, array and linked list the linear data structure, but they have a certain difference. What the difference is, the main difference is how they use the memory, and then time complex of certain method. What does means method, right? For example, for in the array, thousand array, each element trying to delete it or insert it. So that's certain method. And that how is the time complexity different array and linked list we stack, right? So that's the difference. We need to come to perspective. How to use the memory? As I said, linked list's memory is distributed, used it. So in between the relationship, they actually link together with the pointer. But arrays just used to only single one pointer. So they just use the single pointer, but they continuously locate this position. That's the reason arrays no needed to extra maintain the position. They just need to move forward, backward to find in every element. So that's the reason in the array we will be sometimes used to, that's pointer being called index, right? Okay. And then we just use the graph to try to explain they said time complexity of certain method, right? So what does means certain method in the time complexity? So it means if you're using the two data structure, if certain method should be different time complexity, right? That's the meaning of the something like this. So so let's come back to let's come back to analyze the array and the linked list when they try to insert one element. For example, here's the insert y in the position of the second position. So it means how they actually use it. When they try to insert y, the other x2, x3, x4, x6, and 5 and 6 will be moved one position. Each of them will be moved. So it means the size of the 6, but actually the v will be moved 5 times. Then included insertion position is already becoming the linear complexity. So for inserting one element for array, actually the linear complexity. Okay, but okay, let's same operation. If I use the linked list, So why the value put it in the before than x? What they're doing is they put this create as a node, then the x1 of the next pointer to y, and then y of the pointer to x2. All right. So that's without moving anything. They didn't change, they didn't move x2, they didn't touch any position and then other extra space. So it is nothing, they just inserted here the position. So this is only the one operation. So you can able to say that's how it's flexible, how it's fast. It's very fast. For example, here's if I use not 5 element, let's say million of the element, right? So when they trying to add it this y in the second position, what the consequence of the time complexity is million, maybe minus 1 times complexity. But for the linked list, what are the value in the linked list store the million element? They will be just spend one operation only. They just inserted, they just linked it to operation. Just take this first pointer to new element, and then take the new element of the pointer to a certain position. That's it. So that's we can from this example we can understand how's different same operation using the different data sheet, how is different, right? So its time complexity is different. It's very time consuming, and then if you're using a certain array, but it is a efficient for operation in the linked list. Okay, so let's do conclusion. Okay, so make a more general. Array is good at, I mean, in general, array is fixed time, right? Linked list is dynamic, okay, because you continuously, as long as the memory size allowed, they will be, continuously added. Insertion new element is very expensive. As I said, there's very expensive because all of the element will be moved almost, right? Insertion deletion is easier, not expensive, right? Very efficient. Random access allowed, that means you can access any position by the index arrays by the pointer. But the random access not, you cannot directly access each element. You have to if you know one of the pointer, then you can go through each element one by one, open and connect to, finally you will be get your element. Element are not continuously, oh no, element are at continuous location. So it means you, in the arrays, each element is neighborhood. So you are my neighbor, and then you are neighbor of the others. Actually, we are always one link another. I mean, actually, it's not linked, but you don't need to link. Actually, we already located in one side of another, so it's continuously. The memory is a block, but this one is not the block. They will be distributed. One located in one position, is others is have a more distance than other position. So which is good if you are, for example, if you link less is better when you're doing the supercomputer, your one PC of the memory is not enough. If you use link less, they will be, continuously extend your application of the memory size in the second computer of the memory. But if you're using the array, there is a limitation, right? So yeah, that's another things we can, think about it. No extra space required to next pointer. Right, exactly. There is only single one pointer. But linked list, they have each of them has a, for next pointer, they has a always extra space needed to store, because, as you can say, there is always each element has a extra pointer position. So that's a reason. And then advantage and the disadvantage. Arrays, random access, less memory need for parallelment, better catch locality. That is, it is bad. Better part is fast insert delete, dynamic size compared to fixed size, efficient memory location utilized because of the, they can always, resizable, even if they can extend to other computer possibly in the, in the theoretically. So it's already, it's technique existed, And what's weakness of the array is slow in the insert and delete, reverse to, the reverse of the result, linked list. But linked list is bad, for them, slow search, but good to insert delete. Fixed size, memory is, dynamic. Efficient memory location because they no needed to extra memory space, but linked list needed to maintain the pointer. They will be each element has extra memory space needed to maintain. So that's pro and con. For this, the table is actually I get from this article, which is this one. You can try to read it, why is they will be, how they, delete no operation is mechanism work. As you can say, linked list is they only have a two point, this being called node head and the tile. Then each of them is linked with another, and then tile has node, that's linked list, being called single linked list, right? So yeah, so insertion operation is different. You can insert in the head, you can insert in the any position, you can insert in the last one. So as well as there's also can able to see some piece of the C++ code. As you can see, node, as I said, structure node, they have a data and next pointer, right? So that's pointer to node. So as you can see, that one's node value, that's the data. So pointer is next one. So using the node to represent each element in the linked list. But there is a, of course, object, data structure has certain operations. So they will be, we can use push. If you remember the name, very familiar with that. Do you remember? It's the stake and the queues used it, push and pop, right? So why they using the push and pop? Because actually linked list can create stick and very efficiently use stick and queue. So that's the reason they trying to use this one. And what's the push operation is if there is a create, there is a head, they give them head, then also new data. What they're doing is actually creating new one, and that's new pointer. Then after that, you give them assigned to the value in the node. Then one is you can add it to head. The case is like the first case, so that's they directly added to the first one. So it is added to head, so you can stimulate it in the I think in the would say stake operation. Stake is just like you can put it in the top, right? And the next one is head, so they will be linked together, right? Those are, if you you already learned what's the pointer, how they created. So it's PP1, you already learned how to use one, right? So I think it's not the new things for you. Insert after. What's the insert after? Actually, they're trying to represent the second case. So this is the second operation for that case. And then last one, maybe insert, append. So append it, they trying to represent in the code in that case. Okay. So what's append? Take this value assigned to nodes. They add it to last one's head. Head to last. This is new node, so they go last one, they net. There is a, and then also last element will be added to node because last one should be represented. If it's not null, you create a new node to head. So it means this should be, if it is the just without any node, that should be belong to such case. If it's the last one, they will be added this one. This one should be belong to if there is a nothing element existed in the linked list. All right. Then that should be, you can run it, you can try to test it, each of the sum operation. You can 10, 20, 30, then you can just get the result. I think it's not, yeah. So that's the worst. If you're interested, you can worst to look at. There is a give the two different kind of implementation. Let me try to spend a little bit time to analyze it. Okay. Next, implement linked list in certain operation. Okay, that's it. Okay, this is Java language. This is C++. Okay. But they doing the same things. And this is a deletion operation. That previous one is the insert. This is a deletion. If you remember, we have a for delete and insert. We always fast performance, right? Delete and delete and insert, right? And not this one. I think there's on some other. All right, here's they represent this thing as well. Deletion, this is C++ code. This is Java code. So I think this is worth to look at sometimes, right? So that's a conclusion. After that, you can able to compare it. That one we already referenced in our lesson, okay? So that's a two good article you can learn from if you are miss some knowledge, okay? All right. Come back to array linked list of complex certain method, okay? Arrays lookup is, byte index, so it's fixed time. Push operation is added something, any place, something in the one side, of course, the fixed time. And then, but you're trying to add it somewhere else, then they will be linear time. That's the reason. Delete is also will be impacted. After that deleted, you will be move again. Insert also same. But for linked list, lookup is not allowed, so you have to loop it. What does means you have to iterate it, go through, you can one by one to compare it, then you can get your value. So that's the reason that's linear time. And the pushes, of course, same. Insert delete is fixed time. There's also another article. If you're interested, you can take this. What's the reason you can able to look at the example. Right. Now I think it should be enough to explain what's the linked list in the relationship, right? So it's time to make a conclusion. So we can use both. We can save this from the content perspective. There is no difference, but from the operation perspective, from the time complexity, space complexity perspective is different. So you should you should has very clear understanding of the when they use array, when they use linked list. So let me ask you a question. Do you remember? So there's a so do you think what kind of operation you going to recommend to linked list instead of array?
Linked list performs better at insertion deletion. Again, like
Yeah,
whenever you
insert
need
delete is
to.
good at for linked list. But what's the time complexity for that operation?
I think it was
Fixed
n
time,
log
right?
n.
Fixed time.
What? Ah, wait.
Yeah.
Yeah.
Insert delete is because of the you just need to link it to a certain position. For example, here's when they insert the y, they just only two operations. One is to take this x of the pointer to y, and then y of the next pointer to x. So this is just only two operations. It's means fixed time, right? Two times it's fixed time. If it's a one operation, 1 millisecond, it's a 2 nanosecond. That's a kind of two fixed time. But for them, it's linear time. Okay. So, but what's the array is good at for? When they use array?
If we already have an array and we need to find something fast in it, an element.
Something what?
If we need to search for an element.
Yeah, if you be trying to operation that search, that's definitely we should use array. If you frequently delete and insert, please don't use the array. You can use the array, but there's another data structure already existed. It's very fast, which is that linked list, right? So that's you needed to balance the choice. Why we needed to some dependent situation, you have clear idea of the how to choose in between the two data structures. So all right, so that's one conclusion. You need to, if you didn't understand it, you also go back to reference those articles. They will be given more details. Okay. Okay. Good. Let's now we needed to explain a type of linked list type. There is a several type of linked list. Depend on situation. One is being called single linked list. What's a single linked list is actually they have a node, and then this node has only the one pointer to next element, and each element has an only one another pointer for pointer to next element. So and then the head is this head, and then tail. Last element is pointer without any pointer. There is no, so it is a single linked list. Okay, but compared that there is also kind of another linked list. This is a kind of, this is just one direction. Okay, you're going to access anything just only one direction. But this one is they have each node has previous and next two pointer. So it means you can, if you I mean continue to go forward and also backward. So that's a very interesting. If you you're trying to do very dynamic operation, maybe some case should be better to choose double link. It's been called double link because they have a two, each node has a 2 pointer, previous one and the next one. Okay. So yeah, so but it is a kind of also as you can see, there is a window compared to single linked list, they have each node has a 2 pointer. It means it's already has an extra space they will be added. So previous pointer, right? So you can think about it. And then last one is circular linked list. As you can see, I mean, if there is something in the situation that actually you're trying to make it loop continuously without breaking, even they don't have a data, so that's being called the circular linked list. What that means is we can use the single linked list to create circular linked list, but when they see singular linked list, the last one should be has no, right? But circular linked list, actually there is a last link, last pointer to head, they becoming the circular linked list. Okay, for the single linked list, let me open the first explanation how they represent. For example, in the code, for example, this is C code, not C++, all right? But there is same things actually. C++ compatible with C, so that's the reason C++, right? I mean, there is one data, then also another pointer, as you can say pointer, right? This is being represented in C++, and then C is pointer. So that's the single linked list. Last one is null. You can say there is a head. This is value 1 to 3. Then this is the C code. They trying to give them space for memory location. Then 1 is data is 1, 2, 3. Then 1, and the next pointer is 2, 2 is 3, and 3 is null. So that's a single linked list. Okay. But this one is double linked list, you already understood. And then also trying to open it another, there should be circle the linked list. Okay, so we can use circle linked list. Actually, the last one, I mean, those always same, exactly same. Only difference is, as you can see, last 3 next is pointer to 1, right? But if you single linked list, the difference is the 3 next is no. Very simple, right? Very simple. So that's a very interesting data structure. But you have to know, you have to understand that why we should use the single linked list, why we should use single linked list, okay? Then why when we should use the double linked list, okay? So, and to compare this single linked list and double linked list, they have a data, okay, let's say a data structure list, single linked list, and then double linked list. Okay, let's say, I mean, what's list is actually the array. Single linked list is get is fixed time, insert is fixed time, search is fixed time, remove is fixed time. I mean, we trying to get best case, the worst case. Double linked list is insert and that always the same. But I mean, arrays get is same, but insert delete is I'm not sure. The answer should be linear time. Yes, linear time, but searches, yeah, right, exactly. And then also those are you can maybe probably you can able to see what does means if you are needed to more details. This article will be give them the, I mean, this is come from the one book, so you can able to read from the source. But okay, but we needed to maybe I think we need to spend a little bit time to analyze the source code, right? How they represent it, okay? So as you can say, how to create this single linked list, double linked list, and circular linked list. I mean, this here, as you can, that's the C code. But if you're not, I mean, this is C code. If you're not, if you are not comfortable with the C instead of C++, then maybe we can that one should be different code. Maybe we can show it later. For example, here's a single linked list. Okay, that one. First of all, this is data. This is a pointer. Okay, next. This should be exactly pointer to next one. So that's a type of node. That's the reason. And then first the initialization at the first node is head, and then 1, 2, 3. There has a, let's say they have a 3 element going to link it together. They're going to put this one organization. Then after that, one give them one memory location, 2 is give them another memory location. It means they had already had a pointer. And as a result, those are actually the pointer. As you can see, those are, we already had pointer. Then we will be, each pointer has a data, you know, the node has data. So that's the reason one that has the value, they assigned value, okay. The next is make it link together. So one next is pointer. Okay, one is object, that is, one is node, that is next is pointer. Is pointer to 2, and then next 2 of the next pointer is pointer to 3. 3 next pointer is pointer to null. So this is single linked list. So last one should be null. So they will be stopped. Then all right, so then one should be this is head, right? And then doubling class, they have a one more extra pointer, which is previous node. So it's the same, exactly same value. They will be at the definition is same. Then they will be give them arrange the memory location, give assign the value. Now it's different kind of things that you have to not maintain the next pointer as well as you maintain the previous pointer as well. So for example, 1 is next is 2, but the 1 there is no any kind of currently no any kind of value, so that's previous null. 2 is next to 3, but previous should be 1. 3 is next to null, right? But previous is 2, but now is one of the node assigned to head. So they will be finished the definition of linked list, okay? And then what's circular linked list is actually the single linked list, right? Similar things, similar definition, initialization, assigned value is same. Now also, you know, make a link together. That's also, but last one is very interesting. So last 3, last element is 3, and then they has a next pointer, actually pointer to first one. Okay, so next pointer to first one. So that's interesting. Then also, I mean, there should be 2 pointer to first element. One is a head, another is a 1. Another is last element of the pointer. So it's been that's a kind of source code we can able to use it. But that's maybe you are not comfortable with the language. Probably I can also recommend to. I think there should be another. Yeah, that's a C++ code, right? So for linked list, I mean this is this is Java. Okay, maybe you are not good at for. If you're good at for Java, take this as an example. Doesn't matter which language you will be using. There's always the same. But probably the environment different, so it is most times C++ faster. Okay, by the way. This is C++ code. So if you're not, as you can say, this is definition of the same as a C, push operation, insert operation. You know, as you can see, they using the new, right, assigned value, but in the C++, actually, memory location and the size, that's only difference, okay? All right, so I think it's I think it is a today's of lesson. Let me make a conclusion now. All right. Okay, before that I make a conclusion, can you please, any question for them? Any question for linked list? Guys, or are you asleep?
I think no questions.
No questions.
No, no questions. All clear for now.
Okay. By the way, I already made a record, so maybe you can repeat read that, as well as I leave this linked list sometimes. Yeah, you can just reference it. This is also fine. So let me do another conclusion. Okay, so linked list is another option, can do same things as array, but some operations you have to choose wisely. So if you're trying to do delete insert operation, please don't hesitate, just take that linked list. If you frequently use the array read-only operation, don't hesitate, just use array. Okay, so it's very important. And then how's important, how's fast? I mean, there is a some article give you more details. They say, yo, which one is fast? Okay, insert delete, and then I think in this article, yeah, that one. If you insert delete, is linked list better. If you search is access array is better. All right, so that's kind of important things. Then there is a several type of very I mean, three types of linked list: single linked list, double linked list, and then circular linked list. This one depend on situation. Probably we will be most time use single linked list, but you can use double linked list, you can circular linked list, depend on situation. Where, for example, if you're trying to, when they doing the ones operation continuously do another operation, I think sometimes the double head of double linked list is better, but very stable operation, not randomly, single linked list always sufficient. By the way, double linked list, they have an extra space they needed to maintain because of they have another pointer you have to manage. So they will be a little bit more space than single linked list, right? And then circular linked list, I think circular linked list, where the situation, if your data set is limit or certain or not, are they going to shrink it? Or maybe they going to keep continuously loop it? I don't know, but I think it should be, you will be find more details. If you're interested, you can find it, Google it. Okay, so that's today's lesson. I hope this should be make sense for you. You can keep continue to learn. By the practice, you will be get more confident. Okay, that's today's lesson.